So let's say this university, KIT University or any other university, right? Because so they have been through this kind of online mode of education. So they want to do experiment and want to understand how does or how do students perform across different lecture modes, across different study modes, right? So one is pure offline classes, lecture based, right? Teacher will come to the class, students will be in front of him or her. Lecture based offline classes. One is online classes, which is going on right now, obviously over in Zoom or Google, whichever method. Then there is the option of self-study, where recorded videos, if you see a lot of courses which you do in Coursera and all those things. So live sessions are not there, right? So obviously there are recorded questions, recorded sessions. You go through it, you read on your own, you keep exam, then you pass that exam, you get a certificate, right? Let's say the university have philosophy or have a hypothesis saying that whether these three modes, the student performance, keeping everything else same, the student's performance varies across these three modes. So college management want to understand whether the examination performance of students vary if different learning methods being utilized, right? Which is what are my variables?
Sir, we have three variables. Lecture
What?
based is one. Online class.
Also, we have two variables. One is code, other is scores.
Exactly. So remember, because if you do that mistake, all your data analysis next onwards will be wrong. I do not. So those are not variables. Those are values. Lecture based is one category of that categorical variable, which is learning mode or learning method, right? So learning method has three values. One is lecture based, one is offline, sorry, one is online, and other is self-study. So variable is learning method. It has three values, right? Lecture based, online classes, and self-study. Because if I take this, like I was mentioning that day, if I take that second row after results, if I remove this row, I'll not have that additional information. For me, that all of them will become a one sample, one group. Because I'm building this one more variable which has three values. So it is creating that three groups. So variable is varying across three groups. That is lecture based is one group, online classes is another group, self-study is another group. So that is my, which is, that will be my independent or dependent variable.
So self-study one.
Can you please repeat?
Sir, which one, sir, is self-study?
No, this learning methods. Learning methods, will it be my dependent or independent?
Those are independent, but the score is
Independent.
So learning methods is my independent. I believe that my exam scores or the students' performance exam scores is dependent on the learning method. So dependent becomes your exam scores, right? What about the performance, exam performance, right? So once you find out that, okay, I want to compare and find out whether there is a difference, right? So I want to find out variation or comparison between different learning methods of what? Of scores out of 100, right? So my independent becomes learning methods categorical. My dependent becomes exam scores metric. So I can go here again. You need not have to refer this, but any case if in case you have doubt. So I want to find differences more than two groups. My dependent variable is metric, that is exam scores. My independent variable is categorical. So here if you see, that is one category. How many categorical variables I have? It is not that how many groups I have.
Two categories.
What are those two?
three are the category.
No, how many categorical variables are there, right? So here when say one category, it is meaning how many categorical variables you have. How many categorical variables you have?
One, sir.
So learning methods, under that you have three categories, right? One is lecture based, one is online, one is self-study, right? Whenever, so one category here doesn't mean the groups. One category means how many categorical variables you have. So whenever I have this single categorical variable, one categorical variable, and another dependent variable, which is metric. Dependent variable is metric, and my independent variable is categorical. One categorical variable. I'll using something called one-way ANOVA. Whenever I have multiple categorical variables, right? Can you give me an example where I can include, or what kind of other independent variable I can bring, which will be a categorical variable? So if I just bring the gender parameter, because here I do not know which is this person. 73, the person who has scored, I know that he has or she has gone through lecture based, but whether it is he or she, I do not know. If I bring that other parameter, another variable, which is gender, then in that case, I'll go by multiple ANOVA. So that is where you will be using something called two-way ANOVA, because there are two categorical variables, right? So I have gender, another category, learning methods, another category, and I want to compare the exam scores, right? But the simplest one which we are going to discuss today, which is about one-way ANOVA, that is where you have one categorical variable and one dependent metric variable. Yeah.
Sir, when it is like written that in two-way ANOVA, that without replication and with replication. So what does that mean?
The replications means you have multiple data for the same category. With replications means you have multiple data points for the same category. If I, let's say, female student, the lecture-based mode, I have 5 data points. So that is with replication. If I have only single data point, one female student for each category, right? One female student who has scored 73 lecture-based, right? Then that becomes without replication, right? So that is when we want to find out whether there is an interaction or not, right?
Okay.
So we'll come back to that. If time permits, we'll discuss the multiple ANOVA. Because what happens, because one-way ANOVA manually you can calculate. Multiple ANOVA, it will be very difficult, complex to calculate manually. Because I'm both going to cover manual calculation and Excel calculation. Multiple ANOVA, obviously I can show you in Excel, but manual calculation again it takes a little bit time, little bit effort.
Okay.
So now the question is why ANOVA, what does ANOVA do, right? If you remember in two sample test, what was our objective? Whether these two groups belong to the first thing what we want to find out, equal variances or not, whether these two groups belong to the same distribution or not, right? If let's say I have these three modes of education, lecture-based, online and self-study, right? What I start to believe that, or my assumption or my hypothesis that they belong to three different distributions, right? So when I say that my alternate hypothesis is that there means, so here what happens, basically I'm comparing means, so the analysis of variance is there. What I'm trying to say is that average performance is different across different groups. That means the average performance in lecture based is different than online classes, is different than self-study. So these three performances, exam scores should belong to different distribution, right? My null hypothesis is no, their means are same, they belong to the same distribution, singular or a single distribution, right? So now what to intuitively, if I want to prove that, how will I prove that? So I'll first consider them, okay, because if my null hypothesis says that they belong to the same distribution, let me put those all the data points as a same distribution, right? Find out their variance, right? Though we do not use the term variance here, but it is similar to that, mean square of sum of square, right? So that again, I'll discuss what is that mean sum of square, but similar to, just imagine the variance we're calculating. So this step of ANOVA is, because I believe that, or I want to prove that these three groups performance is different, and all hypothesis is no, group performances are same. They are not actually three different groups, they belong to same group. Their performance, exam performance, if I just take exam performance, it is same across all these three, this category, whatever we have provided here, 3, 4, that depends. It can be anything more than 3. Now the approach is I put them into a single distribution. I take this data, consider that as a same distribution, right? If I believe that to be true, right? If I believe that they belong to the same distribution, right? So let me show visually how it happens. I have one distribution which is online classes. Let's say this is a normal distribution. It can be anything, right? I am not worried about that. Let's say it is a continuous normal distribution, something like this, right? So mean score will be here, wherever this highest line is there. Then I have self-study, that is another distribution. Lecture-based, it is 3 distribution, right? My alternative hypothesis is these 3 are different. Their performances are different, right? For the population, because obviously for the sample it is 3 different means 63.5, 69.5, 75.5. What my null hypothesis says, no, they belong to a one distribution, one big distribution, they belong to a single distribution, right? Now what I want to prove that whether these three are different or they belong to a single distribution. All hypothesis means of all three groups are equal. Alternative hypothesis means are, so when I say means are equal means they belong to the same distribution, means for all these will belong to the same group, or means are actually different, so scattered, so different from each other that they belong to three different groups, right? So here basically if you look into the approach or the calculation part, what basically we are doing, we are trying to find out how different this means from this total mean. I will calculate something called total mean. So I'll take this all the data points. I have right now 18 data points, 6 each, 6 in online classes, self-study and lecture based. I'll take this 18 data point. I'll calculate a total mean. What I'm trying to find out, how far this, so between group, so the distance between groups, distance between this online classes with total mean, lecture based classes with total mean, self study with total mean. So that is the difference between groups. So that is one my numerator divided by distance within the groups. Remember, if some of you have gone through that something called cluster in your marketing classes, lot of times segmentation happens. How does segmentation happen? We do something called cluster analysis, right? So we carry out cluster analysis and say that those clusters should be, what is the formula of clusters, or what is the statement of clusters? Mutually MEC, mutually exclusive, collectively adjusted, right? So that means it is covering everything, but these groups are mutually exclusive. That means these groups are different. Mutually exclusive means these groups are different from each other. And within the group, the similarity is there. If I take a group of, let's say, customers of tier 1 cities, how much they like kind of spend in holidays, tier 2 cities and tier 3 cities, what I'm trying to tell is there is a difference in expenses between tier 1 cities, tier 2 cities, and tier 3 cities. So that difference is big. Within that group, tier 1 cities, those customers, their differences are small. So that is where you do carry out segmentation analysis. Mutually exclusive, collectively adjusted. Same situation here in ANOVA. I want to find out the differences between three groups: online classes, self-study, and your lecture based, and find out whether the differences between these three groups is much more than the differences within the groups. If I consider them as part of a same group, if I consider them all them to be part of the same group, what is the difference? So I am trying to find out between groups. So what are those three groups? I have these three. So not necessarily always it will be three. In my case, there are three groups. Sometimes it might be 4, 5, any number of groups. I want to find out what are the differences between these two groups, between groups. Then divide by within groups. Within groups means within this online classes, what is the difference? So what do you mean by difference? Difference is nothing but distance from the mean. If I say that this group is represented by a single number, that is 63.5, what is the distance from the mean in this group? What is the distance from this mean in this group? What is the distance from mean in this group? Combine them. So that is the differences within groups. So I have something called distance or differences between groups, then divided by distance within groups. That will give me something called F statistics or the ANOVA statistics, right? If that value is very high, then what will be my intuitively, what will be like my assumption? Yes, because the ratio is distance between groups, differences between groups divided by differences within groups. Let's say that ratio is 10. So intuitively what will understand? The differences between groups is 10 times higher than distances between within groups. That means differences between groups is too much. Then that means that there are actually three groups. But let's say the distance is very small. If that ratio comes as between groups divided by within groups is very small, 0.5 or 0.2, then that ratio is very small. That means it is almost as if they belong to the same group. There is not differences between groups, right? Because the distance between groups is very small in comparison to within groups, right? So the all the aspect of philosophy or the approach behind ANOVA is find out the differences or distance is through self.
So, if the ratio is small, we can say that null hypothesis is true. They belong to the same distribution.
Ratio is not so okay. So now the question is, when I say very high or very small, what should you take? Whether you should take 1, 2, 5, 10, right? So there should be an answer for it, right? Like she mentioned, if it is 1, shall I take the ratio as 1? So that is where your critical value, because it depending upon your sample size, depending upon number of groups, that value will change. If that value is greater than that critical value, you will say that groups are different. If that value is within that critical value, you will say that groups are same. Groups belong to same distribution. So to answer your question, we do not take that as 1 because it is because there is a standard. So it need to apply for any data you take, right? So depending upon your sample size, depending upon number of observations, number of groups, that value changes. Sometimes it can be 2, sometimes 3, sometimes 5, depending upon your data size. And that is what we are trying to find out. That is critical value. So we find out test statistics, we find out critical value. If my test statistics is greater than critical value, what I'll say, the mean square differences between groups is comparatively larger than mean square within groups, the distances between groups, distances within groups. That's why I can say that all these 3 or 4 or 5 groups are different from each other. Is it clear?
Yes, sir.
Okay. So now going back to the I'll show you some formula, but do not try to remember the or kind of mug up the formula, because that's why it will be very difficult. Try to find the approach what we are taking, right? That's why it will be easier. Even if you forget so try to always come back to this step. This if you can visualize what we are trying to find out. So I believe that this belong to a single group. So I first find out the total mean of this group. For each group, I find the distance from the total mean. So this is the total mean of 18 data point, or whatever data points is given in your exam or your project. So that will give me something called the numerator, mean square between groups. Then within each group, I find something similar to variance, right? The variance numerator. Then if the between groups distance is much more than within inside group differences, then I say that null hypothesis can be rejected. So just to look into the calculation part. So this x double bar is nothing but, if I consider all of them to be a single group, what is the total mean? So x double bar is nothing but total mean. Do not go by the complexity of this formula. This formula is actually very simple. Each observation you find out the distance. So I have 18 observation. I find out the distance from the mean, sum it up.
Total
For 18 observations, so that gives me the total mean. So what my philosophy or what my logic says that these total differences, total distances from the each observation from the total mean can be divided into 2 parts, right? So this distance can be divided into 2 parts. That is the distances between groups, that is sum of square between. Then distances within groups, that is within the group whatever the variance. So if you see this formula, so for each group I have a mean. So xj bar is nothing but for each mean what I'm calculating minus total mean. This is x double bar. If I believe that they belong to a single group, then nj is nothing but the sample size for each group, not total sample size. Nj means the each group how many data points you have. So if I sum it up, this gives me something. If you see, this is nothing but, if I just take out n, nothing but this is your numerator of your variance, right? So in variance, what you do? You calculate the differences from each data point to the mean, then divide by the number of data points. That will give you the average distance, average variance. Then take the square root, that will give you the standard deviation. Same formula here. Here only we are doing it by weighted average, right? Because I have 3 groups. Then this is something called known as sum of square between. If some of you have gone through regression, this is actually in the regression also huge. What I say, if I total variation, total distance of my model is sum of square total, and how much I am able to explain. Sum of square total is nothing but the explainability of the model, sum of square between sum of square model, then sum of square error, what I'm not able to explain. So my R square is nothing but sum of square which is defined or which is explained by my model divided by sum of square total. How much variance in the model I'm able to explain through the equation I have put, because that equation I can write in 1000 different types. the equation which I have chosen, the assumption which I have made, how correctly it is able to explain the variance, right? So when we discuss regression, we discuss something similar to this. So that is also we take a ratio. When you talk about F statistics, sum of square or the explainability of the model divided by sum of square total. So here again similar type. So sum of square between, actually we do not divide by sum of square between, we calculate something called mean square, right? But here is the catch. So generally when you calculate average, what we do? Number of data point, right? Because we are calculating it for again for our sample, right? So remember what will be our, how many groups are there? I have 3 groups. C is nothing but
Sir,
number of,
SS between we'll calculate for 3 times, sir. Like for each group.
for each group, you multiply it by the number of sample. That will, if you add that up, that will become sum of square between. So when you say 3
So
times means yes, for 3
for
groups.
for 3 groups, like the X bar will be different, right?
Yes, yes.
So for 3 times we have to calculate, right?
Only 3 times for SS between, sir, because there are
Yes.
3 different.
Yes. So yes, so that depends on the number of groups, right? Because in my case, this is 3. In your case, if it is 5, then you have to calculate 5 different means. So it depends upon number of groups. It is not always 3. Here, because I have 3 groups, lecture-based, start online mode, and whatever the other is self-study. Depending upon number of groups, you have to calculate. Yeah. So we calculate something called mean square between. It is nothing but sum of square between divided by column minus 1, number of groups minus 1. Then mean of square within, that is again sum of square within divided by, don't remember, try to remember this formula. It is nothing but total number of observations. Cn is nothing but total number of observations minus total number of groups. So I have 6 into 3, 18 number of observations minus 3 groups, 18 minus 3, right? In your case, let's say there are 5 groups, each has 4 observations. 5 into 4, 20 observations minus 4, right?
Minus 4.
So again, like what we discussed, what we are trying to find out, whether the differences between groups, that is mean of square, that is the differences, distances between groups, is compared to mean of square within is very high number, right? If this number is very high, then I'll say that yes, there is a huge distance between these groups. I might confidently, with 95% confident, I can say that these 3 are different groups, means will be different, right? If the ratio is very small, I will say that no, means seem not to be that much different. Might be same, I do not know. I cannot prove that they are different, right? So now, like what? Yeah.
So high in the sense it is more than
Yeah.
1 and
Yes,
low in the
exactly.
sense
So Trusali was mentioning. So whether I'll take it as 1, right? If it is ratio greater than 1. So I said no, that number is not fixed. That number is nothing but, if you see, that boundary is variable, right? Depending upon number, if sample size, number of groups, that number varies. That number is nothing but your critical value, right? So when I say it is high or it is low, I'm comparing with a number. That number is not a fixed number. It is not that 1, 2, 5, 10. That number varies, and that number is nothing but critical value. So this is my test statistics.
Okay,
I find critical value. I compare it. My test statistics greater than critical value. Then I say that number ratio is very high. I reject null hypothesis. If that ratio is small than that critical value, I say that I cannot reject my null hypothesis, right? So that to answer your question, same question I think Rusali was also answering, that is not a fixed number. That number is nothing but your critical value.
Yes, sir.
Okay. So just to, again, I'll show you in Excel. So we are calculating first what we are calculating, sum of square between, right? So I have all the group means for each individual group. I have calculated mean 63.5, 69.5, 75.5. If I take the average of it, 69.5. So that is my total mean, right? So why do you think I have taken average? Why I'm dividing by 3? On which case I cannot divide it by 3?
I mean, number of group, it depends upon us. So in this
Correct.
case, we have 3 different.
So when I'm, let's say if there are n groups, I'm able to divide by n. But what is that condition?
We'll have 10 different means, and then we'll divide it by 10. We'll add.
But what is that condition? Only when you will divide by 10, 5, 6. What is that condition? When your sample size is same. See, it is a weighted average.
Yes.
Yes, sir.
Yes,
Yes.
Here,
yes,
each
sir.
of them match 6, right? If you see, actual formula is 6 multiplied by mean of online classes, 6 multiplied by, so it is nothing but a weighted average, because every time it has same sample size, 6 divided by 18, it becomes 3. Imagine the scenario, 10 online classes, 10 students who are from online classes, 12 from self-study, 15 from lecture-based. Then I cannot just divide by 3, right? So what will happen? 10 multiplied by whatever the mean, plus 12 multiplied by this, 15 multiplied by lecture base, divided by 10 plus 12 plus 15, right? Here,
Yes.
the formula becomes little simpler because we have all like weighted average, nothing
Same
but your
sample size.
simple average, right? So the like answer is whenever weighted average is equal to simple average, when the group size is same, the number of data points in each group is same, whether it is 6, 10, 15, 100, it doesn't matter. Each group have same number. Each group have different number, then weighted average calculation, actual calculation you have to do. So this is my total mean. So now the step is whether this variation from the total mean is so big in comparison to within mean differences, right? So next step is to find out differences from all these means what I've got from the total mean. So that will give me the sum of square between. So 63.5 minus 69.5 square. So that is the differences of my online class from my total mean. Self-study 69.5, it is the same mean from my total mean. Lecture based, the mean came as 75.5 minus 69.5, right? So I multiply it by the number of data points, right? Not necessarily always the data points will remain same, right? Here I have 666 for all the data points, it is same. So total sum of square between becomes 432, right? So what it means, if I assume that it belongs to a single distribution, and I assume that these are 3 different distributions, what is the distance from the total mean, right? So I add that up, that becomes 432, right? So this is the sum of square between groups, right? So remember, I'm not comparing with online classes, lecture based with self-study with online classes. I'm assuming all 3 belong to a big distribution, single distribution, and I'm measuring the distance from the total distribution, right? You see here the differences is not that online classes with lecture based, online classes with a single distribution with this total mean, right? 63.5 minus 69.5 square multiplied by 6, that is your sample size. Same thing for your self-study, same thing for your lecture based, right? Add that up, it becomes 432. Then I divide by the degrees of freedom. That is my
So
number.
why do we square these differences?
Because if I add it up, because see, I'm always interested in the
That's
distance, right? Sometimes the distance can be negative, positive, right? It will be huge distances, but it might cancel it
Yes.
out, right? Same situation for the variances. In variances also, I'm measuring distance. But why the question of squaring? Because unless I square it, some will be positive, negative, and when I add that up, overall distance might be 0. But each point is at a different data point from the mean. So
Yes.
that's why we're squaring it up. Any other questions on
in this
this?
case also it will get to 0, sir, if you don't square.
Yes. So basically, if I do not make a square, there is a chance that it will become positive, negative, equal, and it will become 0. So what will mean that they belong to same group, but which is not true, right? Which might not be true. I do not know whether it is true or not, but which might not be true. So this gives me a value of mean square between. Again, it is the differences, mean square, mean differences between groups, right? Then within is nothing but you just calculate the differences within the groups. So 58, what is the 58? And let's say I'm just taking one example. Online classes, I have these 6 observations. So first student is scored 58. 58 minus 63.5, square of that will give 5.5 square, that is 30.25. Then 73 minus 63.5, square of that 90.25. So these is the differences within the group of online classes. Similarly, I find out the differences within self-study group, the differences within lecture-based group. But see which mean I am taking. Mean for that particular group.
Individual.
Individual mean, right? Not the total mean. So then I take the distances, I take the differences, then add that up, that becomes 4870.5, right? Then I divide by the degrees of freedom. Degrees of freedom is total sample observations minus number of groups 18 minus 3, 15. That gives me the value of 324.7. So what it means that within the groups, if I take the average distance, add it up, it is becoming 324.7. And when I took distance between the groups, it became 016, right? So now the ratio part. This step is not required. This step is just to show you that the first formula which I showed, the sum of square total. If I consider all the data point to be a single distribution, now what I'm doing? So all these 18 data points belong to a
73
single
minus
distribution.
69.5.
Correct. So total mean square of that. Then if I take that overall distance from the total mean, that becomes 5302.5. So this total mean is divided into two parts, sum of square between and sum of square within. So sum of square between I had got 432, sum of square within I got 48.70.5. So this value which I had got 4870.5, 432 I had got. So this is just to show you what we assumed in the beginning, that is correct, right? Sum of square total is equal to sum of square between plus sum of square within. This step you do not have to do. That is always true. This is just to show you that this is the optional step, not required. So if test statistics, mean square between divided by mean square within, that gives me a value of 0.66, right? Intuitively also you can see that this value is very small. You can say that there is not much difference between the groups, but again I have to prove it statistically, right? Because I cannot take based on my own understanding the ratio should be 1, 2 or 5. So for that I have to find critical value. So I have to go to the F distribution table. Like we discussed before, F distribution table will have two different degrees of freedom. Degrees of freedom of the numerator is mean square between, which I am putting in the numerator. So their degrees of freedom is nothing but number of groups minus 1. 3 minus 1 is 2. Degrees of freedom in the denominator, that is total sample size minus number of groups. Total sample size is 18. Total sample size is 18 minus number of groups. How many number of groups you have? 3, right?
15.
10, right? So 215, if you find, it is 3.68. So now you are comparing with that number, whether it is high or low than this number. Because my test statistics is this number, critical value is 3.68, test statistics less than critical value, I cannot reject null hypothesis. So I'll say that with sample size 18, confidence level 95%, we could not reject the null hypothesis. So though it looks like they belong, the average mean scores are different for the sample, but I cannot prove that there is actually a difference in population, right? So the performance is not that different in the population, right? So that will be my conclusion. Is this steps clear?
Yes, sir.
Yes, sir.
So quickly, let us try to do that in Excel. Where is this? So again, so same question if I get into, same information is given. So remember, every time you have to write all these things in your like kind of exam paper. So what is my study and comparison across 3 groups, right? So that is what I want to do. What are my variables?
Scores and different groups.
Scores is metric. Then your what is that like
Mode
learning
of
method?
education.
Yeah, mode of education, learning method, that is categorical. Then dependent becomes your scores.
Score is dependent, learning method is dependent.
Alternate hypothesis. There is
Means
a
a lot.
so like that also you can write, or otherwise whatever is my
So can we write
research.
a descriptive statement for each position?
Yes.
In this case, we can. Okay. Sir.
There is a difference in marks across different learning methods. Null hypothesis will be status quo. There is no
There is no
difference.
difference.
Right. So ANOVA is very simple. As long as you know the data analysis method is ANOVA, right? Go to data analysis. Just a moment. Click on the data analysis. See, ANOVA single factor. And any statistics factor means your independent variable, right? And your whichever variable you are studying. So how many independent variable I have, right? I have only one independent variable. In case same thing, what that time I was asking question. Apart from your lecture-based online classes self-study, I had also another variable. So this is one variable which is learning method, learning mode that has three values: lecture, online, and self-study. If let's say I have another variable, let's say gender, right, male and female. In that case, I have two factors. What are those two factors? Gender is one factor.
Gender
Then your learning mode is another
mode of
factor,
learning.
right? Then I am trying to find out whether exam scores vary across learning methods also vary across your gender also, right? In that case, it will be two factors.
Sir, in that case, we'll have two F stats, sir.
Two abstract, yes. Correct. So in that case, again, there are two differences: with replication, without replication. When we have multiple data points for a same category, sorry, for an intersection of two category, then it will be with replication. Replications means replication of data point. If I have multiple data points with replication, if I have single data point, we'll call it as a without replication. But the design remains same or the statistics remains same, right? So that is when
So-
you will have, yeah.
Then in this case, if we add a third, fourth column as a gender, then this solution, I mean, this question will be ANOVA two factor with replication, right? Because these three have
Yes. So let me show you example where it will be like, let's say in this particular case, what I say, these are male student, male, male. Sorry. Then these are female. So now what happens for this category? So intersection of this category, male and lecture based. How many data points I have? I have actually three data points. So the data is getting repeated. So male student, lecture based, I have three data points. So this becomes a lecture, sorry, this becomes a two factor. So what are those two factors? I have gender as one factor. I have another factor which
score
is
as another
learning method. No, score is your dependent, right? Learning mode.
okay, learning method, yes.
Learning mode is another factor, is always your independent variable. So I have two factor, right? So one is gender, another is your learning mode, and I have multiple data points for intersection of these categorical variables. When I say male and lecture based, I have actually three data points of male student who have gone through lecture based, right? These I can little bit vary. I can say that this is from I am A, this is so let's say these are the 6 IIMs, right? So I want to understand whether this mode of education, that is one variable, learning method, and the institute type, different IIMs, right? So there are 6 different values for that IIM, whatever IIM or education. I can take school, kids, school of management, XIM, BMDI, like that. I can take 6 institutes. So in that case, what happens? For a single intersection, IIM Ahmedabad and lecture based, I have only one data point. Right. That is where you are without replication will happen. Right. Is it clear or any doubt?
Yes, sir.
So
Yes,
how
yes.
the comparison is done when we have two categorical factors? Like if we had another factor gender, then the way we calculated, how would we calculate the difference? Sir?
So it will be one, your equation will be, let's say, let me show you through an example. Let's say this is my there, male and female, right? So what does it mean actually? I need not write male again. Male means these are three male students who have gone through lecture base. These are three female students, right? So I'll go here. So what are my hypotheses, right? So one hypothesis, which is here I have written, there is a difference in marks across different learning methods. Then there will be another set of hypotheses where will I say there is a difference in marks across genders, male and female, right? So rather than creating two different ANOVA in the same ANOVA, I'm able to try to find out. So first set of hypothesis is there is a difference in marks. Yes, Harsh Prakash.
And what if we have another factor as profession, where
So for the
student and working professional they are like the factors. So
Yes, you
have
can
to
do
write
that.
the third.
So you can do multiple ANOVA, but in Excel, no. Excel, you have only option for two factor. SPSS, other things, you can do multiple ANOVA. Yes, through cell.
Okay.
So for the second hypothesis testing, we will have two groups then.
Two groups, yes.
Okay.
Then when you have replication, there is an intent to take multiple data points where we are saying whether there is an interaction. Interaction effect means like if you have gone through this regression method, one variable impacting your independent variable impacting your dependent variable, male gender impacting your result. Similarly, your mode of education impacting your result. Whether both the variables together impacting your result. In that case, it becomes an interaction effect. So in this particular case, we'll have actually three set of hypotheses. One is which is written here, there is different across marks and different learning method. Another set of hypotheses, there is difference in marks across gender. Third set of hypothesis is there is a interaction effect between gender and your education level or the mode of education. What does it mean? Both combined together, right? Because in regression, what you say, keeping the other constant, whether there is a impact of the other variable. Interaction effect means if I take variables together, two variables have an interaction effect on the whatever exam performance or your. So if you just click here, go to data analysis, ANOVA two factor with replication, input range, select like this. So rows for sample means how many replications you have. So if you see you have three replications, right? You have three data points for rows. Male, how many data points you have? Three. Female, you have three data points, right? For each row, for each intersection, you have three data points. Then put output range.
So, but we can have like for male, we can have 4, and for female, we can have 2.
So in yes, so that is a good question, but in Excel you cannot do. In Excel, it is only possible when you have three. So it is not that you have to always, like you said,
So
it is
what
not.
will be the HO and HA in this case, in the when we are seeing the impact of learning method as well as the gender on scores? So what will be the null hypothesis and alternative hypothesis in this case?
So you'll have three set of hypotheses. One is for this one is for sample. So this you said there are three F statistics here. Okay. So your first is for columns. What is in your columns? Your lecture-based online classes self-study. So you'll say that whether there is a difference in marks across columns, across your learning methods. So that is your first set of hypothesis. Then your second set of hypothesis across rows or across sample. Whether there is a, so alternate hypothesis will be there is whether there is a difference across gender, male or female, right? So that is second set of hypothesis. Third set of hypothesis is whether there is an interaction effect between male, not male, whether there is an interaction effect between gender and your learning methods. So to answer your question, there you have to write three different hypotheses there. First hypothesis, there is a difference in scores, there is difference in exam scores across columns, across your whatever learning methods you have, right? Then sample, there is a difference in scores across gender. Then interaction, there is an interaction effect between gender and your whatever score like learning method you have. So what will
This is
happen
how
here?
we have to frame the sentence, like
Yes,
there
you have
is
to write.
okay.
You have to write. Then accordingly, whatever value you get. So all the three hypotheses you are not able to reject because
Harsh has disconnected, sir. He's waiting in the room, waiting room.
Yeah. Okay. Okay. So this is how you do a kind of a two-factor ANOVA. But coming back to our question was a single point ANOVA, right? So let me just, okay, I'll have space here. So coming back to what we wanted to prove, right? We just digressed a little bit. What we wanted to prove, whether there is a difference in marks. Let's say this male and female data is not available, right? Or I'll not consider that, right? Let's say I just want to understand whether there is a difference in marks across these three learning methods. I'll go to data analysis, ANOVA single factor, okay. Input range is, I'll select all the data. Grouped by how your data is grouped, right? So here I have grouped data in lecture-based online classes, self-study, right? Labels in first row, that means the first row will be considered as textual information, right? Output range right here. So if you remember, these are the values which you had got in manual calculation, right? 216 mean square of error, 324.7, that is your within groups. This is between groups. This is within groups. The same thing I had shown you in slide. If I take the ratio of this 216 divided by 324.7, that will give you the same value as your whatever F statistics you have got, 0.66523. Your critical value in the table we have got 3.68. So if you got here also same 3.68232, right? So same conclusion will get, my F statistics is less than critical value, so I cannot reject null hypothesis, right? Is this part clear or any doubt?
Okay, sir, can you show the that exercise sheet once more?
Which one? Data analysis.
Yes, sir.
Data analysis. So select this data, then group by columns.
Yes, sir.
Alpha is automatically 5%, and that anyway
Yes,
we
sir.
continue. Okay.
Yes, sir.
So you'll get similar
Sir,
kind of result. Yeah.
So this labels in first row. So what is it like?
It says that the
Is it?
first row is a textual information. That means you are putting labels in the first row. If I discard
Oh,
that,
okay.
it will, so I'll select only these numbers. I'll not select the text.
Okay, sir. Okay, sir.
Okay, so quickly do the other part. So I've given you exercise, another exercise, quickly do it within 5 minutes. Anyhow, you can write this. So what is the question? FMCG company, they like, this is something known as experimental design or market testing, right? So most of the time they test product, so all the marketing mix, product, pricing, promotion, channel, right? Try to understand what is impacting their sales. So let's say Nestle or Maggie or any company for their instant noodle. So similar stores, three different type of similar stores for last 6 months or 6 weeks, they have been observing. One kind of store, they are providing no discount, same as in your MRP. Another type of store, they are providing 5% discount. Another type of store, 10% discount. The product manager or the marketing manager thinks that your sales is dependent or sales will vary across different discount rates. Sales will vary across different your promotional strategies, right? So what will be your alternate hypothesis? What will be your null hypothesis?
So
Does this
sales of instant
does
noodles of the brand vary at different discount rates or offers, and all null will be do not vary.
Sales vary across different discount rates and sales do not vary, right?
Do not vary. Null hypothesis.
So quickly carry out the analysis and let me know what is your answer, whether you are able to reject null hypothesis or not. What is the answer you got? Whether null hypothesis got rejected or could not be rejected. Yeah, quickly. What is the problem?
Sir, so between like I have like I got the data, but I'm little facing difficulty to interpret. Like we have to see the F statistics done, right, sir?
Yes, so
Sir,
you have to tell
it
me.
is-
I have already explained. Yeah, Nanda.
So F value is 37.4482.
Okay. So what is the result there?
That's critical is
The
3.3.
test yes, sir. The test statistics is more than the critical value.
What will happen?
Sir, what's the critical what's the critical value, sir? Like
It's given.
sorry,
So if
I mean like if we how we have to measure it, like leave the F value with the critical value, so it should be like more or less.
So now you have to tell me. You have completed 7 sessions, and now you are asking me. And in the beginning itself in the class, I repeated that. And now even if you ask me whether I should take more or less, then there is no answer, because if you are trying to remember the setup, I can give you in writing, you will face difficulty in exam. So if you try to remember, yes,
Sir, I
Jyotirmay.
think I have got the wrong value.
Yes, Jyotirmay. What will be that if I get a statistics is some 37 point something, and my critical value?
We have to reject the null hypothesis, sir, because our calculated value is greater than the tabulated value.
Correct. So ANOVA single.
I got the wrong value, sir. I guess it's 3.7 something.
Check that how you have taken the values.
Yes, sir. I haven't like included the last data. That's why it's showing like that.
Okay.
So see, calculation part is like Excel is doing it for you. Luckily you are in online mode, so this calculation you are not doing manually. So see like how much relief you have. Still, if you are able to not find that how whether to reject or not, in the first, second classes, first 4 or 5 classes, I can imagine, because that is something you need to understand. Now you have repeatedly shown, each class I have been repeating what is the approach of a hypothesis test.
Sir, my critical value was coming like it was coming higher because I haven't included the last table. So that's the difference. That's why it was difficult to interpret.
So can anybody tell me why degrees of freedom is 27 here or within groups? How
So
did
30
they?
minus 3.
Yeah.
30 minus.
So total sample observations is 30. You have 3 groups. 30 minus 3 is 27. Here you have 3 groups, between groups -1, n minus 1 is 2, right? So because my
from column and 27 from row, sir, in F table.
Yeah.